Hello everyone, this is Mrs. Nyman. We are on Unit 7, Chemical Reactions and Quantitative Changes. This is Section 1, Reading and Balancing Chemical Reactions. So chemical reactions occur when substances that have a reason for exchanging ions, electrons, or protons come together. A chemical reaction can be written in one of two ways. We can use either a chemical equation, which is something like this. We have seen a chemical equation before, or it can be something more like a word equation, which is a sentence. We haven't really written these before, but we've practiced naming, and this is a really good way to incorporate the naming that we used in last semester. So I want you to take a second, and I want you to go ahead and answer this question right here. We've used all of these symbols here before, but you might not have remembered these. It was in the reading that you did. So, guest teacher, go ahead and pause the video for a second. So that should have been fairly easy for you, for the first few at least. Solid was C, liquid was F, gas was A, aqueous was D, and/with, that was the plus sign, that was option E, and makes/yields is the arrow. So you use the arrow anytime you're saying this is when the reaction actually occurred. Anything after this is a product. In a chemical equation, the substances that are found to the left of the arrow are called the reactants, and the substances that are found on the right side of the arrow are called the products. So we're going to use two different color highlighters to make a key so that we're going to highlight the reactants and the products in the word equations. Let's just do actually let's do both the word equations and the chemical equations. So the products I'm going to do in red, and the reactants I'm going to do in blue. So up here in the first one, so remember the reactants in, oh Jesus, what jeepers, what did I do? Reactants in blue. So we've got reactants blue. That's what you start with. So we are starting with the Na solid and the sulfur solid over there. So that is the solid sodium and the solid sulfur. Over here with the other side of the arrow, we have the Na2S, and we have solid sodium sulfide. So just a reminder on those rules, when you are naming ionic compounds, you always name the element first. So the element that came first was sodium. It is always going to be the metal that you write first. So that's why sodium is first. And then for the last element, sulfur, you change the N to "ide." Always to "ide." Unless it is something like this, where you have more than two elements. And if you have more than two elements, you are going to look on your polyatomic ion sheet, and you are going to find nitrate like that. Down here, we have silver nitrate, aqueous. That matches up to silver nitrate dissolved in water. Remember, dissolved in water, that's the definition of aqueous. And it is reacting with copper. So that with means those are both reactants. And that is a copper solid, so solid copper wire. And then we have copper nitrate. Now, copper is a transition metal, and transition metals get something special with their name. You do not need to learn how to do this. You'll never be tested on this. But this Roman numeral here is actually the charge of copper, because copper can have either a +1 or a +2 charge. So the name actually gets the charge inside it. And then we have silver solid. So this should look familiar as a single replacement reaction that we saw last unit, where the copper here must have a higher reactivity than the silver in order to kick it out. Woohoo! Bringing things back around. C6H12O6 solid. That's called glucose. I would not expect you to know that that is glucose, but that is glucose. Reacts with oxygen gas and oxygen gas, and that yields, so the yields means the arrow, H2O and CO2. That's liquid water and carbon dioxide. Alright, so at this point what I want you to do is I want you to go get your word equation practice, and I want you to complete the word equation practice. You should feel comfortable naming anything that is an element by itself. The thing I would suggest to you is remembering Brinkelhoff. I'm going to write that right up here. Brinkelhoff. Remember, those are elements that cannot be by themselves. Bromine, iodine, nitrogen, Brinkel, chlorine, hydrogen, oxygen, and fluorine. Remember, they either have to be in a compound or they have to be with another buddy of themselves. So they would always be written like I2 or O2 because there are two atoms of oxygen inside one molecule of oxygen gas. So that's a reminder that you might need. The other one is that you should feel comfortable naming anything that is a group 1 or 2 metal, so alkali metals, alkaline earth metals, or aluminum. You should feel comfortable naming anything that is by itself, like copper here. Anything that has one charge, like silver nitrate. Any of these polyatomics, like nitrate, sulfate, any of those found on your placemat. But I would not expect you to name one of these with the Roman numeral and the inside with the parentheses. That is for a metal that has more than one charge. You are never going to be asked to name that. I would always give that to you on a test. Just like you can see on your word equation practice, I give that to you. So when you're done with the word equation practice, check your answers on the answer key on my website. Then you can play the video and move on. So guest teacher, please pause the video one more time while the class works together with their small groups to finish the word equation practice. Chemical reactions do not create or destroy atoms. They only become rearranged or form new compounds. So it's really important that you understand that anytime a chemical reaction takes place, that causes a chemical change. We are creating something completely new, but the atoms are the same. The atoms are just put in a new order with new chemical bonds. So this means that chemical reactions, like all that of science, are based off of that of the law of conservation of matter. So we've got this example below. 2A plus B, and then we've got our arrow, so reacts to form or yields A2B. In this equation, we have two atoms of A that are going into the equation. So 2 atoms of A are going in. That means that 2 atoms of A have to come out. So notice that at the beginning, the A atoms are not bonded with the B atoms, but they are at the end. That's not important. The important thing is that the number of atoms of A are the same at the beginning and the end, and the number of atoms of B are the same at the beginning and the end. So we are going to be counting a lot in this. So this really isn't that difficult of a section. You're really just adding, maybe multiplying, depending on what you're doing. You should feel fairly comfortable with this. I'm going to throw something a little bit extra at you. I want you to name these three. This one in particular might be a tiny bit of a challenge, but go ahead and do that along with counting the atoms of each of these elements. So guest teacher, go ahead and pause while class goes ahead to count the elements and to name those three compounds. All right, so here are your answers. Notice that in blue for number 5 and 6, I showed you the final answers. Just for the subscript answers, I have those in red down at the bottom. And then I multiplied it by the coefficient, so the times 3 here. That's because of this 3 in front of the ALNO3. It multiplies all of these coefficients times 3. Same with this 4 here. It multiplies all of these coefficients times 4 because of that guy. For the naming, those are all polyatomic ion naming. You should feel comfortable with any of those ones. The other options we haven't learned how to name, so I would not expect those of you. Okay, so at this point, this is what an unbalanced equation looks like. H2 plus O2 makes H2O. So we notice that 2 atoms of hydrogen go into the reaction and 2 come out in the products. However, only 1 oxygen comes out in the products. This means that our equation is not accurate. So the way I like to think about this is daycare. So let's say that I'm babysitting my nephews, David and Teo. Now, I'm gonna babysit David and Teo, and we're gonna go to the zoo, and we're gonna go to the park, and then I'm gonna bring them back, but I'm only gonna bring back Teo. My sister is not gonna be happy. You can't just lose a child. Same thing with atoms. You cannot just lose atoms. They cannot just poof out of existence. Also, if I took David and Teo on all of these adventures, and then I randomly picked up a 3rd child, Lillian, and I brought my sister David, Teo, and Lillian, she doesn't want a 3rd child. And whoever Lillian's parents are probably want her. So, you can't just steal children, and you can't just disappear children. It's against the law. Same thing with atoms. It's just against a slightly different law. Okay, so here's how you do this. In order to make sure that you're not going against any sort of laws, you are going to make sure that your coefficients that you're going to use to multiply children or atoms, those have to be whole numbers. You can't be multiplying by half a child or half an atom, half a molecule. It doesn't work like that. You also cannot change any of the subscripts. Remember, we talked about how H2O is something I can drink. H2O2 will kill me. So I can't just change that to H2O2 in order to balance that equation. That's bad news bears. It still has to be the same substance. So subscripts cannot change at all. The other rule, that's really not so much of a rule, it's just going to make your life a lot easier, is don't start with oxygen. There's a really long story about why it's the last thing you want to do, but just don't start with it. All right, let's start with this guy down here. Now, you might look at this and be able to do it very easily. You might not, but let's start out with a very simple process. Something that a lot of people like to do is start out by just writing down the number of atoms of each element. underneath each element and compound, and then some of them even like to write a line down the middle between the reactants and products. That way they can very easily distinguish between what is on the left side and what is on the right side. So remember, the goal is to get the same number of atoms. So right now we can easily tell that the iodines are our problem. So in order to change that, the only thing we can do is change coefficients, so I can only multiply. So in order to do that, I'm going to put a 2 out front. That changes my sodium, and that changes my iodine. So sodium goes to 2, and the iodine goes to 2. So I fixed my iodine problem, but now I created a sodium problem. So I'm going to need 2 atoms of sodium. So what this is really telling me is that I need 2 atoms of sodium for every 1 molecule that contains 2 atoms of iodine in order to make 2 molecules of sodium and iodine together. So the better you get at this, the less you'll have to actually write down the number of atoms at the bottom below each compound. But if you want to do that on your unit test, then do that on your unit test. If you don't want to ever do that because you can already see this in your head, then cool, go for it. It doesn't really matter. You can show your work or not. I just want to see a correct final product on the balancing. Okay, so what I want you guys to do is go ahead on the next page, and I want you to start off by writing down the atoms for each element in each compound. And then I want you to go ahead and balance the equation. Leave the part where it says tip blank. Guest teacher, if you could go ahead and pause to give them a minute. Alright guys, so here is what you should have come up with your starting numbers, and I'm going to work you through this just in case you struggled a little bit. So the first thing that I noticed was that my potassiums were off. So that's what I'm going to start with. On the left side I have 1 potassium, on the right side I have 2. So I'm going to fix that by putting a 2 out in front. So that's going to change that to 2, this to 2, and this to 6. So now my potassiums are good, my nitrogens are not. So the next thing I'm going to do is fix my nitrogens. So I'm going to go over here on the right side, and I'm going to put a 2 over there. That gives me 2 hydrogens, 2 nitrogens, and 6 oxygens. Now, you didn't have to go in this order. You could have started with hydrogens. Remember, the recommendation is never to start with oxygens, but that's really the only rule. And that's just because oxygens would have made this messy. But other than that, now we have 2 hydrogens, 1 carbon, 1 carbon. We have 9 oxygens here and 9 oxygens there. Woohoo! The whole thing is balanced. But there is actually an easier way with something like this. So give me a second, I'm going to write out the tip, and then I'll be right back. Alright, here we go, here's the tip. If you have polyatomic ions, like NO3 or CO3, and if they do not break up, it's important that it must be NO3 on the left and NO3 on the right. CO3 on the left and CO3 on the right. If they're the same exact thing on both sides, then you can count it up as one unit rather than breaking it up into its individual elements. Here, I'll show you what I mean. Alright, so if I counted the nitrate ions as one thing, then this guy would have 1 nitrate ion at the beginning. Carbonate would have 1 carbonate over there. So just keep it together and count it as one unit. So that way, when you put a 2 out in front, you change that, and now you just need to multiply the nitrates on the right side. And it's just fewer things to have to multiply, and it makes it a lot faster. So, at this point, you've done all of your notes on balancing equations. I want you to go through and do the more practice at the bottom of this, and then you are going to check the answer key on my website. When you are done with that, there's a large balancing practice. I want you to do as much as you need to do to feel comfortable. The more you do, the more comfortable you're going to feel. This is going to have to be something that you can do very, very, very quickly. So you need to practice until you can do it very, very, very quickly. I would also be practicing naming because you are going to have a quiz coming up that incorporates naming, counting, and balancing, along with reading equations.